Oh, because you're making...
Alright guys, this is your video for 6.4 and then we'll do 6.5 tomorrow. 6.4 and 6.5 are the same thing as 6.2 and 6.1 were with parallelograms. On 6.2 you said, hey, this is a rectangle, or hey, this is a parallelogram, what do you know about it? I know this, this, and this. And then 6.3 was, hey, here's this figure, can you tell me if it's a parallelogram or not? So 6.3 and 6.4 are the same thing, only we're going to do it with rectangle, rhombus, and square together. So for 6.4, I'm going to tell you whether the figure is a rectangle, a rhombus, or a square, and then you're going to use the properties that are on your quad chart to tell me what other information you can know based on that. So for example 1, we have a rectangular picture frame. So on your quad chart, you'll want to go down to the rectangle section and look at all those properties there. So JK is 50, and JL, this whole diagonal, is 86. And the question wants us to find HM. So since HM is a part of a diagonal, we are working with the diagonal, so I really don't even need this 50. So if JL is 86, then I also know that KM is 86 because that's a property of a rectangle, that the diagonals are congruent. So it's a rectangle, therefore the diagonals are congruent. So this whole thing, from here all the way across is 86. Well, if you move up your quad chart, you get to parallelogram. So all rectangles are a parallelogram. So we can also use any of the properties that are directly above our figure on our quad chart. So I can also use the properties of a parallelogram here. A rectangle is a parallelogram, therefore the diagonals bisect each other. So HM would be half of KM. These would be cut in half. So HM would have to be 43. So you don't just use the properties of a rectangle. You can also invoke the properties of a parallelogram because a rectangle is just a special kind of parallelogram. Okay, so first this figure TVWX is a rhombus, so we're going to use our properties of a rhombus, and just like the last example, we can also use properties of a parallelogram since a rhombus is a special parallelogram. So it's asking us first to find TV. Well, TV is a side, and I don't have an expression for TV, but what I do have is an expression for two of the other sides. And because it's a rhombus, I know that all sides are congruent. So I can set any of the four sides equal to each other. It doesn't have to be, and they're all going to be the same. So I'm going to set 3b plus 4 equal to 13b minus 9. So 13 would be equal to 10b. So B would be 1.3. And because I'm looking for TV and I don't have that, I can plug it in to any of the sides that I want to. So I can either plug that into 3b plus 4 or 13b minus 9. It doesn't matter. Either way, I would get 7.9. 7.9 would be the side length for TX. It would be the side length for XW. It would be the side length, excuse me, for all of the sides since it's a rhombus. Okay, why don't y'all pause here and you try to do part B with the angles. Okay, so here's yours right here. You have to use two different properties of a rhombus to get to this, but you know you're working with angles, so you have two choices, this one and this one. So I started with the interior angle since we know that in a rhombus the diagonals are perpendicular. So I set that interior angle 14a plus 20 equal to 90 and solved and got a is equal to 5. Then the picture gives us angle XTZ, this angle on this side, but we're asked to find VTZ on this side. But luckily we know that in a rhombus the diagonals bisect opposite angles, so those two angles are congruent to one another anyway. So I plug it into one side, I plug it into the other, they're equal, it doesn't matter. So when I plug in my A is equal to 5 here into 5a minus 5, then I get 20. Okay, example 3. Show that the diagonals of a square are congruent perpendicular bisectors of each other. So we did this kind of thing with the parallelogram, and I let you kind of choose which object you wanted to do, if you want to do opposite sides or parallel or whichever one. For this one, and I told you when you do diagonals, you kind of get two for one because you can use them for multiple things. Same story with a square. But we have three things we have to prove for it to be a square. We have to prove the diagonals are congruent because that's a property of a rectangle. And so we'll do that with a distance formula, Pythagorean theorem, same thing. Perpendicular, so that helps us prove that it's a rhombus. So we'll do that with slope. And then bisector, when the diagonals bisect each other, that's a property of a parallelogram, and we'll do that with midpoint. So by proving congruent perpendicular bisectors, we're proving parallelogram, rectangle, and rhombus. And when an object is a parallelogram, a rectangle, and a rhombus, then we know for sure it's a square. So we're kind of working our way down the ladder with the algebra. Okay, so here we go. So let's start with congruent. So we have two diagonals here. We have EG. So we'll start with that one first. So I like to just do Pythagorean theorem, especially we're already on a graph. We're already here. So we have EG. If you make your triangle, we would go over 1, 2, 3, 4, 5, 6, 7. And up 1. So that would be 49 plus 1 is the square root of 50. So that would break down, and technically I guess you don't have to break it down, but we're good at that anyway, so we'll do that. So 5 on the square root of 2. Okay, now we're going to do the exact same thing for FG, or for FH, sorry. So FH is my other diagonal. Okay. So here we already know that's 1, and then let's count 1, 2, 3, 4, 5, 6, 7, all be darned. Square root of 50 is equal to 5 on the square root of 2. So the diagonals are congruent, therefore it's a rectangle. Okay, now so let's go on to perpendicular. And remember we've talked about this a couple different times before. The beauty of doing distance and slope at the same time is that those numbers work together. So here we go. EG, I already know because I already counted this. I already know I'm going to rise up 1 and run over 7. For FH, I already know because I just did this for distance. I'm going to go down 7 and over 1. So 1/7 and -7, those are opposite reciprocal slopes. I flipped it and changed the sign. So therefore they are perpendicular. If the diagonals are perpendicular, then it has to be a rhombus. Okay, let's hope I don't run out of room here. Okay, so my last object to do is to prove that they're bisectors. So we're going to do that. Won't let me erase anymore. We're going to do that, proving that they have the same midpoints. So for E is at -4, -1, and G is at 3, 0. So when I add those up and divide by 2, I'm at -1/2, -1/2. Okay, F is at -1, 3. H is at 0, -4. Looky there, -1, -1, divide by 2. So this one also has a midpoint of -1, -2. So having the same midpoint means that the diagonals are bisecting each other. They're cutting each other in half. So since the diagonals bisect each other, I know it's a parallelogram. So I can say because it's a parallelogram, a rectangle, and a rhombus, it has all the properties of all of those, then I know it's going to be a square. So a lot of work on that one, but work that you've done consistently every chapter throughout the year. So hopefully by now you're pretty comfortable with it. Look, a proof. I bet everybody's so excited, and I bet you're doubly excited that it's a 10-step one. Okay, here we go. ABCD is a rhombus, so the whole thing is a rhombus. E is the midpoint of AB, and F is the midpoint of CD. Prove that AEFD is a parallelogram. So basically we have an entire rhombus, we do midpoint, midpoint, and we're trying to prove that now it's 2 parallelograms. Okay. So I'm going to put all of these givens in one step. Since it's already 10, we don't want to make it 11. So A, B, C, D is a rhombus. E is the midpoint of AB. F is the midpoint of CD. Okay, I know I want to do A, E, F, D is a parallelogram. So what I'm going to do is I'm going to use the properties of a rhombus to break this stuff down throughout the middle, and then by the time I get to right here, I should be proving some of the properties of a rhombus, and then I'll go in, if it has the properties of a, I'm sorry, using the properties of a rhombus to break it down. Then by here, I should be talking about that the AEFD, the bottom half, has some property of a parallelogram. So then I'll prove that it's a parallelogram. So that's the overall goal here. Okay, so what do I know about a rhombus? All right, so let's start. Well, let's connect the two. I know if the figure is a rhombus, then it's also a parallelogram. And that's kind of from our quad chart. A rhombus is just a special kind of parallelogram. So if it has the properties of a rhombus, it is inherently also a parallelogram by nature, so I can use those properties together. Okay? Which, if I know it's a parallelogram, then I know that AE has to be, has to be parallel to FD, because in a parallelogram, opposite sides are parallel. Good. Okay. So then next, what else do I know? Well, I know that opposite sides should also be congruent. So I know that AB, the whole side, has to be congruent to CD, the other side, because that's a property of a parallelogram. And a rhombus is a parallelogram. But notice I don't say that it's a rhombus, therefore opposite sides are congruent. That property comes under the parallelogram chart. So I use it with a parallelogram. That's why it was important for me to tell you, hey, even though they told me this is a rhombus, it still has the characteristics of a parallelogram, because I want to invoke those characteristics in my proof. Okay, so now let's switch over into equality so I can do stuff with this. Okay, so now let's get into this midpoint stuff. Well, what does it mean to be the midpoint? Well, it means that AE is half of the whole side length. Same thing on the other side. FD is half of CD, because if E is the midpoint, then that means it cuts it in half. So the bottom half is half of the full segment. And that is just definition of a midpoint. Okay, so now I'm going to do some swapping around. So see over here I said AB was equal to CD. Well, now I'm talking about AB and CD. So I am going to substitute one into the other, and it doesn't make sense. It doesn't matter which way you do it. So I'm going to say FD is equal to half of AB. So what I did is I took AB and I substituted it in the place for CD, because AB and CD have to be equal. So I substituted it on in there. Okay, this step is a little bit confusing, but we're going to do the transitive property. And here's what we're doing. Remember, transitive property is if A is equal to B and B is equal to C, then I don't need B anymore. I can go directly from A to C. So that's what we're doing here. And here is my bridge. See how both of these are equal to 1/2 AB? So what I'm going to do is I'm going to say if this is equal to 1/2 AB and this is equal to 1/2 AB, well, then they must be equal to each other. So AE must be equal to FD because they're both equal to 1/2 AB. That's the hard part of this proof. That's the confusing part. So you might want to rewind and watch that again if you missed it. Well, I switched into congruenceville, or into equiland, so I'm going to need to go back. AE is congruent to FD. And look what I proved here. So up here in the top, hold on, let me change colors. I proved that AE was parallel to FD because it was part of a parallelogram already, so they were already congruent. And then down here, I proved that AE was congruent to FD. So I have one pair of opposite sides that is both congruent and parallel. Therefore, it's a parallelogram. Remember, this was that special condition that you learned about in 6.3. It's not on your quad chart because it's not a property, it's a condition. It helps us solve things faster. Okay, I want you to give this one a shot by yourself. And here, it looks daunting, but it's not. Here's what you're doing. Here, this is a rhombus in here in the middle. So you're going to use the properties of a rhombus to prove that these big triangles are congruent. So think side, 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 angle, side. And once you have that these big triangles are congruent, then you can use CP/CTC. So take a second and see if you can get to here. Here is to prove, use the properties of a rhombus to prove the triangles are congruent, and then here CP/CTC. Pause and give it a go. Okay, here we go. And some of these could have been in slightly different order. So if yours doesn't look exactly like mine, that doesn't mean you're wrong. So I started with the given. It's a rhombus. And then what does that mean? So I'm going to use the properties of a rhombus. And I used 2 of them, so you can use those in any order. I used the rhombus, the diagonals bisect the opposite angles. And that helped me if this diagonal is coming through and it's bisecting this angle. Then that helped me to say that this angle QPR is congruent to this angle SPR. Or TR, you can use them interchangeably because it's all along the same segment. Okay? And then the other one that I used was that all sides are congruent, and that helped me get QP is congruent to PS. So anytime you have angles that are triangles that are sharing a side, you know, whoopsies, you know you're going to have to use the reflexive property. So the reflexive property helped get me that one right there. So there's my 3 pieces that I needed for the triangle. A side here, the angle being bisected over here, and then the reflexive side over there. So the triangles were congruent by side, angle, side. And if the triangles are congruent, then so are all the other pieces. So RS and SR have to be congruent by CP/CTC. Okay, so this is it for 6.4. We will go over it and do some more problems like this in class tomorrow, and then we will do 6.5 for tomorrow night's homework.